Welcome to this lesson on pointers in C++. Pointers, references, and dynamic variables are essential concepts in C++ programming. They allow you to manipulate memory efficiently and create dynamic and flexible programs. Let's explore these concepts in detail. What is a pointer? A pointer is a variable that stores the memory address of another variable. Instead of holding a value directly, it points to the location where the value is stored. Why use pointers? Pointers provide several benefits. Dynamic memory management. They enable allocation and deallocation of memory during runtime. Efficient passing. Large objects can be passed to functions using pointers instead of copying them. Complex data structures. Pointers are crucial for implementing linked lists, trees, and other advanced structures. To use pointers, follow these steps. Pointer declaration. The asterisk indicates that the variable is a pointer. Address operator. The ampersand retrieves the memory address of a variable. Dereferencing. The asterisk is used again to access or modify the value stored at the memory address. Here's a simple example to demonstrate the basics of pointers. In this example, PTR holds the address of X. Asterisk PTR dereferences the pointer to access the value of X. One powerful use of pointers is dynamic memory allocation. It allows developers to manage memory at runtime, providing flexibility and efficiency when working with data structures and resources. Here's why it is considered powerful. Flexible memory usage. With DMA, you can allocate memory at runtime, meaning you don't have to decide in advance how much memory you need. This is helpful when the amount of data varies. Efficient use of memory. You only use memory when you need it and free it when you're done. This saves resources and prevents waste. Dynamic variables are created during runtime using pointers. They allow flexible memory allocation. Here, the new operator allocates memory dynamically and frees it. Always set a pointer to null PTR after deleting it to prevent dangling pointers. Nicknames. In C++, references act as nicknames for variables. They allow you to work directly with the original variable using a different name. Unlike pointers, references cannot be null and must be initialized during declaration, without copying their values. Let me give you a practical example. Imagine you have a friend named Ivan, but you don't call him by his full name, but rather, for example, you call him Vanko. Here is the difference between pointers and references. Initialization. Pointers can be uninitialized or set to null, while references must be initialized at declaration. Reassignment. Pointers can point to another address, while references cannot be reassigned. Use cases. Use pointers for dynamic memory, arrays, complex data structures, and for references, use function parameters. Pointers make it possible to create arrays dynamically. Common mistakes. Uninitialized pointers. Always initialized pointers. Memory leaks. Forgetting to free dynamically allocated memory. Dangling pointers. Using pointers after freeing memory. Null dereferencing. Always check if a pointer is null PTR before dereferencing. Here are some practice tasks. Write a program to reverse an array using pointers. Implement a program to find the maximum element in a dynamic array. Don't worry to ask for help. In this lesson, we explored pointers, dynamic variables, and references, nicknames in C++. These tools give you powerful control over memory and program behavior. Mastering them is essential for advanced programming and building efficient applications. Happy coding! Let me know if you'd like additional examples or explanations.